Today we're going to be solving this classical physics problem from topic 2, which is little Timmy of mass 50 kilograms accelerates from rest to some final velocity. He does this in a distance of 15 meters, and his acceleration is due to a dog pulling on a rope which is attached to him. The dog pulls with a constant force of 400 newtons, and little Timmy experiences a force of friction on a flat surface with a coefficient of friction equal to 0.5. What's his final velocity? Things we know are his mass, 50 kilograms, the displacement, 15 meters. His initial velocity is 0 meters per second because he started from rest, and we're looking for his final velocity. We know the coefficient of friction, which we can use to find the frictional force along with his reaction force, and we're going to do that by starting with a free body diagram. This right here is little Timmy. There is a vector for the force of gravity on him, mg, and the reaction force, r, from the surface he's on. There's also the force pulling him, the dog, 400 newtons, and the frictional force opposing the motion, which we can find using mu times r. Now, Newton's second law states that the sum of the forces is equal to mass times acceleration, which we can split up into x and y components, defining positive y as up and positive x as right. And we'll split this up doing the sum of the forces in the x direction and the sum of the forces in the y direction. So MA here and MA here. Now we know that this dog is just pulling him along a flat surface. He's not going up or down, so there's no acceleration in the direction, in the y direction at all. So this means acceleration is 0, and r minus mg is also 0. So the reaction force is mass times the gravitational acceleration. And using his mass, 50 kilograms, and taking acceleration due to gravity to be 10 meters per second squared, we get the reaction force is 500 newtons. Now, in the x direction, it's a little bit more complicated. The acceleration is not 0 because these two forces are not the same. He's moving in the direction that the dog is pulling him. So we have the force of the dog minus the force of friction, and this will equal mass times acceleration. We know the force of the dog to be 400 newtons, which the problem gave us, and we know the formula for the force of friction, which is mu, otherwise known as 0.5, times r, which we found to be 500 newtons. And this all equals his mass, 50 kilograms, times A. Now, multiplying these out, half of 500 newtons is 250 newtons. So we get 400 minus 250, and this gives us 150 newtons is 50 kilograms times his acceleration. And dividing both sides by 50, 150 divided by 50 is 3 meters per second squared is going to be his acceleration. So, using this information, we can now go to two-dimensional motion using Francine, which is the equation v squared equals u squared plus 2 times a times s. And we have all of these variables up here except for v, which is the final answer that we're looking for. So plugging everything we know in, we get that v squared equals 0 squared, because he starts from rest, plus 2 times the acceleration we just found, 3 meters per second squared, times the displacement, which the problem told us was 15 meters. Multiplying this out, 2 times 3 is 6, and 6 times 15 is 90. So we get v squared equals 90 meters squared per second squared. And taking the positive square root on both sides, because he's moving in the positive direction, we'll find that v equals 9.487 meters per second. And I promise that's right, but here it is on the calculator. Square root of 90 equals 9.4868, blah, blah, blah. Call it 9.487. And this is the final answer. Exactly what the problem was asking for. Little Timmy's final velocity. And for Gucci gang, you're done.